Okay guys, second video in our video series of sequences in series. We're going to be talking about arithmetic sequences. Arithmetic sequences are going to always have something called a common difference. We'll define that in a minute, and then we'll talk about how to write the terms. We're going to create a general formula so we could find any term that we wanted, and then finally we will find the sum of the first n terms. Okay, so first piece in definition of arithmetic sequence is just some sequence that has a common difference. Each term differs from the next by that common difference, and when we think about difference, that means subtraction. So this is always going to be sum or difference. Okay, so we're either going to be adding some number to get the next term or subtracting some number to get the next term. And we're going to use D to represent that common difference. Okay, so an example here, if we want to figure out what our common difference is each time, we're just going to subtract any term minus the previous term, and if they always remain the same, then it is arithmetic. So 5 minus 1 gives 4, 9 minus 5 is 4, 13 minus 9 is 4, so that means our common difference here is 4, and this would have to be arithmetic. You'll see here if we take 3 minus 7, negative 4, negative 4, negative 4 each time. So in this case, since we're reducing, it's going to have a common difference of negative 4. Now, if they didn't all have the same difference each time, it would not be an arithmetic sequence. It could be something called geometrical, which we'll talk about in the next video, or it could be neither and just some kind of random sequence that we have. To write an arithmetic sequence, then to write the first few terms, we're just going to apply that common difference to the first term and repeat. So a sub 2 here, 200, if the difference is 20, the next one has to be 220. And then a sub 3 is 240, and a sub 4 is 260, and so on. Okay, if this had been a negative number, we'd just be reducing. We'd have 180, then 160, then 140. So again, negative 7, this then tells us that a sub 2 is going to be negative 3 because we're adding 4. A sub 3 is going to be positive 1, a sub 4 is going to be 5, and we could keep going on as far as we wanted for any term that you asked for. So this way is kind of like the recursion stuff we were talking about in the last video, where we need the previous term to find the next term. Now there is also a general formula we can create that would tell us any term we wanted a sub n, and that formula is always going to be your first term, a sub 1, plus the number of terms, n minus 1 times your common difference. And the thing we're going to need obviously then is our first term and our common difference each time. So if we look at our first example here, you can see our first term pretty easily. That's 1. And if you applied the rule, 5 minus 1 is 4. Again, just like that previous example, our difference is 4. So a sub n would equal our first term plus n minus 1 times our common difference. And now, suppose I wanted to know a sub 50, I wouldn't have to do the previous 49 terms. I could just plug in 50, and that would tell us what a sub 50 equals to if we put that through the calculator. Okay, the next one then, a sub n equals, so we're going to have a sub 1 plus n minus 1 times our common difference, which you see we're reducing by 5 each time. So now I'm going to say times negative 5, and so that would be our general formula for that one. Again, we could do the same idea. Plug in any value we want for n, and that would tell us what term number we have, what value we have for a specific term number. Okay, our summation formula then is only going to be for the first n terms. It could not be all of them because no matter what your sum or difference is, it's always going to grow out of control. So we've got the formula s sub n equals n over 2 times a sub 1 plus a sub n, where obviously this is your first term, a sub 1 is the first term, a sub n is the nth term or the last term in the sequence, s sub however many terms, and the number of terms divided by 2. So in order to do this first one, we need to have, we're looking for the first 20th term, so that's going to be s sub 20 equals 20 over 2, and then a sub 1 we can see is right here is 4, plus what we don't know is this term a sub n yet. So what we actually need to do is figure out our general formula. So a sub n equals 4 plus n minus 1, and in this case we need our common difference. We'd have to look at our sequence, and I see that we are increasing by 6 every time. So that means that a sub 20 is going to be 4 plus 20 minus 1 times 6, and that gives us an a sub 20 value of 118. And so we could plug that value in right here, and now we can find the sum of the first 20 numbers. And by plugging that in and simplifying, we're going to get 1,000 220. That would be the sum of our first 20 integers, or first 20 terms in this sequence. So that is it for this video. We talked about common difference. Remember, that's just how far apart or what you would add or subtract from one term to get the next term. And then the big piece there we talked about was our general formula. A sub n equals a sub 1 plus n minus 1 times d. So you need your first term and your common difference for that one. All right, see you next time.